Okay, let's take a look at Chapter 3, Pictorial Drawings. Okay, and pictorials are really nice for illustrating design ideas. Okay, of course we can look at a 3D drawing or a 2D drawing and look at the three views and tell what it looks like, but not everybody can. Sometimes we need to have a little extra there so that we can show the true shape of what this is going to look like. Okay, and pictorials are used to help the print reader visualize the part. Here is a part, okay, and this is what it looks like in 3D. Okay, now normally with a part like this you wouldn't put a pictorial there. it it's very easy to do, as you'll see in Inventor, but we don't need to do it, but we will anyway. Okay, pictorials are very effective at illustrating assemblies, and we will draw some assemblies later on in this class. Okay, and there are different types. Okay, the basic types are axonometric, which is the most common, and that is one of those is called an isometric. There is an oblique. The most common oblique is a cabinet drawing, and then there are perspective drawings, and I'm sure you've all seen that when they show a railroad track going to a point if you're looking straight down the railroad track. Okay, here is the isometric, here is the cabinet. Okay, and you can see the difference. Now we will be only drawing isometrics, okay, but we'll look at what a cabinet is as well. Okay, axonometric. Okay, there are three types. There's isometric, dimetric, and trimetric. Okay, here is the isometric. Okay, this line here, these lines going this way, these two are at a 30-degree angle. This is vertical. Okay, these are all drawn to scale. Okay, here in a trimetric, we can put a different angle, trying to make it look more realistic. Okay, so we can pick any angle that we want there. Now we can do that in Inventor just by moving it around. Okay, here is a dimetric. Okay, these are not drawn to scale, but they're drawn to the same. Okay, they're not drawing the true length, but they are the same. So if we foreshorten this one a little bit, we'll do this one a little bit. We will not be doing any dimetric drawings. Okay, here's some examples. Can you guess which is which? That's an isometric, trimetric, and dimetric. Okay, oblique projections. Okay, on oblique projections there are three different types. There is cavalier, cabinet, and a general. Here is a cavalier. Okay, this is 0 to 90 degrees. These are drawn full scale. Okay, you'll notice though that the front view, okay, is drawn as a basic front view. It's drawn right to scale, the true size. Okay, on a cabinet oblique, okay, the difference is back here, and you'll see this is probably a little distorted if you make this full scale. This is half scale. Okay, here it's scale, but it's not full or half. It can be either one. Okay, perspective, we have 1 point, 2 points, and 3 points. 1 point perspective, they all go back the same. 2 point perspective, we go this way and that way. You see that it's a little less distorted. And then 3 points is, okay, the most realistic drawing or a realistic view. Okay, here's an example of two drawings in Inventor. Okay, this one is drawn to perspective and this one is drawn in the isometric. Okay, looking at either one of these, they both look okay. Okay, the perspective kind of makes it look more of how it would look if you were looking at the real object. Okay, and again, obviously, since these were both done in Inventor, Inventor has the capability of allowing us to draw in perspective. Visualization, visualization, which is very hard to say, is the ability to picture in your mind how a 3D part would look as a 2D orthographic projection and vice versa. Okay, I think in my experience that this just takes time. You'll get better at it the more that you do it. It is very tricky at first, but the nice thing about it is that in Inventor, if we draw it as a solid object, we can automatically get an isometric, get a perspective drawing, and get our 3 views. Okay, why is it important? When your 3D CAD program automatically creates a 2D orthographic projection for you, whoops, just took off. Sorry about that. Where is it? There you go. Okay, so inspect the drawing and determine whether it's technically correct or be able to translate a part print into a solid model. Okay, based on the orthographic projection shown, circle the one that is the true shape of the object. So which one of these 3 looks like this one? Okay, it would be that one there. Okay, which one would that be? Would be that one there. Okay, isometric, important to remember that it is 60 degrees from this, from the vertical, and it's 30 degrees from the horizontal. Okay, we do not worry about this 80% of full scale. Do not worry about that. Okay, here's an example of 3 views and an isometric. We're going to draw this later when we get into faces and planes and surfaces. Okay, so in the exercise, it's going to be the next video. We're going to draw this one, put it on a piece of paper and make an isometric. We're going to draw this one, put it on a piece of paper and create an isometric. Okay, that is it for chapter 3.